Hello students, today we will be solving the IB Math A till May 2025 paper 2 Tension 2 question number 10. You will be getting the solutions to the other 9 questions, the first 9 questions of this paper and the solutions for the other questions from the other past papers in form of playlists on my channel NS Online Math Tutoring classes. You will also be getting playlists where the solved past paper questions will be available based on their topics. I'm Nilanjana Sanyal. I am an online IB Math A level tutor. My phone number and my website address are displayed at the bottom of the screen. So without any further delay, let us start to solve the question number 10. The maximum mark is 17. Adam's apple orchard. The weights of apples W in grams are normally distributed with a mean 175 grams and standard deviation 8 grams. Okay, so W is a normal distribution variable with the mean as 175 grams and the standard deviation as 8 grams. So variance is 8 square or 64 grams square. Okay. So part A's question is find the probability that a randomly chosen apple weighs less than 170 grams. Okay. So probability W is less than 170. And this should be equal to, we will be using the calculator, menu, and then I can take the probability option number 5 and then number 5 again for distributions, and then it will be the normal CDF option number 2. Less than 170 grams. So the lower bound stays as it is, the upper bound is 170. The mean is 175 and the standard deviation is 8. Okay, so it is norm CDF. We have to write this. It is better to write this because we are not showing any working. Norm CDF. CDF is caps. CDF, and then you can write negative infinity. You can write, or you can write minus 99999 anything, or you can write the number that is written in this format, minus 9 times 10 to the power of 999. So anything. And then upper bound is 170. Then mean is 175. And the standard deviation is 8. And this is equal to 0.26598, and also correct to 3 significant figures, it will be 0.266. Okay. 0.266. Correct to 3 significant figures. So part B. It is found that 20% of the apples weigh more than W grams. Find W correct to 4 significant figures. Okay. So P of W greater than small w is equal to 20%. So the probability will be 0.2. And since we have to find the value of the small w, we have to use the inverse normal option. Therefore, we have to change this greater than sign to the less than sign. So this is equivalent to writing P of W less than W is equal to 1 minus 0.2, which is 0.8. Okay. And now using inverse normal, menu, and then again option. You can use option 6 also, statistics, and option 5 will be for distribution. I'm using probability, option number 5, and option number 5 again for distributions. And now it is option number 3 for inverse normal. The area is 0.8. It is always the less than area. So 0.8, and the mean is 175 and the standard deviation is 8. It is 181.73 correct to 4 significant figures, they have said. So it is 181.7. Okay. And the command is inverse norm, INV, and then N is in caps. Okay. So this is therefore in norm. This is okay, let me write W equal to, therefore W equal to in norm, and 0.8, mean is 175, and standard deviation is 8. So this is equal to 181.7. Okay. So W is equal to 181.7 grams, correct to 4 significant figures. All orchards classify an apple as premium when its weight is between 170 and 185 grams. So part C's question is find the percentage of apples that are classified as premium at Adams Apple Orchard. Okay, so let me answer this part C over here. So it will be probability. We have to give the answer in percentage, but first of all, let us find the probability. It will be W will be between 170 and 185. So 170 is less than W is less than 185. So this is equal to, again, it will be norm CDF, and the lower bound will be 170, the upper bound will be 185, and the mean will be 175, and the standard deviation will be 8. So this is equal to menu, and okay, this time let me take statistics, option number 6, and you see option 5 is distributions, and it is distributions, and it is normal CDF, so option 2. Lower bound is 170, upper bound is 185, mean is 175, and standard deviation is 8. It is 0.628. Okay, 0.628 I am taking. Correct to 3 significant figures. Most probably I have a number less than, yeah, 5. It is 0.6283. So it is 0.628. Okay. So this is equal to 62.8%. Okay. This is the answer for the subpart C. Okay. After orders are completed, there are many apples left over. Boxes are filled with randomly chosen leftover apples. Each box contains 40 apples. Okay. So part D's question is find the probability that a randomly chosen box contains at least 30 premium apples. Okay. So each box is containing 40 apples, and out of these 40 apples, at least 30 should be premium apples. Okay, that means they will be weighing between 170 and 185 grams. Fine. So over here, we are having boxes which contain, each box is containing 40 apples, and an apple can be a premium apple or it can be a non-premium apple. Okay, so there are only 2 outcomes, premium or not premium. And the number of trials, that means the number of apples in this case, is fixed. It is 40 per box. And the probability of an apple being a premium apple is 0.628. Okay. Obviously, I'll not be taking only 3 significant figures. I'll be taking more number of digits, but this is the probability of success. So we are, and the probability of one apple being premium apple is not in any way affecting the probability of another apple being a premium apple. So the trials are independent. So therefore, this is a case of a binomial distribution. Okay, you have to first of all understand that. And what we are finding is the probability that a randomly chosen box contains at least 30 premium apples. So we are counting the number of premium apples. What is the binomial distribution variable? That we have to first of all define. Okay, so it is the number of premium apples that are present in the box. So therefore, let us write x be the normal binomial distribution variable, and number of trials is 40, and the probability of success is x will be giving us the number of premium apples that are present in a box, randomly chosen box. Okay, and the probability of success will be 0.628, and after that, what is, let me take 2 or 3 more digits, say 365. I am taking 365 46, so I am taking 365. Okay, and now we have to get the probability that at least 30 means 30 or more, so greater than or equal to 30. We have to find the probability. So this should be equal to, this is a binomial distribution, so again menu and then option 5 probability, option 5 distribution, and it is binomial CDF because it is greater than or equal to 30. It is having an inequality. We cannot use the binomial PDF option. It is the binomial CDF, option number B. Okay, so number of trials is 40. Probability of success is 0.628365, and lower bound greater than or equal to 30. So the lower bound is 30, and the upper bound, each box is containing 40 apples. So the upper bound has to be 40. Okay, so binom CDF, okay, 40, that is the number of trials, then the probability of success, and then the lower bound is 30 and the upper bound is 40. Okay, so this is equal to, so 0.0739 I can take, correct to 3 significant figures, 0.0739. Okay, so 0.0739. So this is the answer for the subpart D, correct to, of course, 3 significant figures. Okay, subpart E. If 10 of these boxes are randomly selected, find the probability that exactly 4 boxes have at least 30 premium apples. Okay, so we have found the probability of a box containing at least 30 premium apples, which is 0.0739. This is the probability of success, and again I'll not be taking 3 significant figures for calculating the subpart E's answer. I'll be taking more number of digits. So okay, fine, so it is subpart E. Now 10 of these boxes are selected, and we have to find the probability that exactly 4 boxes. So again, this is a case of a binomial distribution, because at least a box can have at least 30 premium apples, or it can have less than 30 premium apples. So these are only the 2 outcomes that a box can have. And there are 10 boxes, so the number of trials is fixed. There are 2 outcomes, and the probability of a box having at least 30 premium apples, that is probability of success, is also fixed. And the probability of a box containing at least 30 premium apples will not be in any way influencing the probability of another box. So each trial is independent. Therefore, it is a case of a binomial distribution again. Okay, but in this case, obviously, we will be taking another variable, because now we are not counting the number of apples which are premium apples in a box. Rather, we are counting the number of boxes in which there are at least 30 premium apples. Okay, so y, let us take y. It is another binomial distribution variable where the number of trials is 10 and the probability of success will be 0.0739, and I have to take some more digits. So I'll not be taking 9. It is 738 and 623 I'm taking, because it is 6228. So 738, 623. 738, 623. Okay, fine. So now we have to get the probability of exactly 4 boxes. So P of y equal to 4. Okay, this should be equal to binom CDF again, or you can take PDF also. Let me take binom PDF, because this contains the equality sign. You can use the binom PDF. Okay, so menu, and then number 5 probability, number 5 distributions, and then A, option A is binom PDF. I can just press this A. Number of trials, it is 10. Probability of success is 0.738623, and the X value is 4. So let me write these: 10, 0.0738623 and 4 equal to, oh sorry, I did not take 0.0738, I have taken 0.7. So this will not be correct. Let me do the calculation once more. So number 5 and then 5 again for distribution, and then A for binom PDF. And this is 10, and this one is 0.0738623, and this one is 4. Okay, 0.07. Yeah, this time it's correct. And we will be having the value as 0.00394. 0.00394. Okay, so 0.00394. So they have asked for the probability, therefore this is the answer. Again, correct the 3 significant figures. Fine. At a neighboring orchard, the weights of apples M in grams are normally distributed with mean mu and the standard deviation sigma. It is known that 82%, so okay, M is a normal distribution variable with mu as the mean and sigma as the standard deviation, so variance is sigma square. And it is known that 82% of their apples are classified as premium, and the premium quality is the apples which weigh between 170 and 185 grams. So P of 170 M 185, because they have said all orchards classify an apple as premium. Okay, so this will be equal to 82%, so 0.82. This is number 1 information given to us, and the second information is the percentage of apples that weigh less than 170 grams is twice the percentage of apples that weigh more than 185 grams. Okay, so if we think of the normal distribution curve, so this may be the normal distribution curve, and maybe 170 is this one, and 185 may be this one. Now you may be asking me that why have you taken 170 less than mu and 185 more than mu? Because we do not know the value of the mean. I have taken this in this way because the probability between 170 and 185 is 0.82, and we know the probability of the entire right hand side means right to the mean is half or 0.5, and the left side is also the total probability is 0.5. Okay, so since 0.82 is more than 0.5, so I have to take some portion from both the sides. Either I can take the whole of the left hand side and a portion of the right hand side, because 0.5 plus 0.32 will be giving us 0.82. So I can take the entire left hand side plus 0.32 probability portion area from the right hand side. That is one possibility. Or else I can take the right hand side, the entire right hand side and a portion of the left hand side. But mind you, if I have to take the entire left hand side, this is extending from negative infinity to positive infinity. It will not be starting from 170. Okay, so that I cannot take. I have to take the lower bound as 170. I cannot go beyond that. So there is this problem for taking the entire left hand side or entire right hand side. And also they are saying from this second information, it is clear, very clear, that there is a portion which just contain the apples that weigh less than 170 grams. And there is another portion which contain apples which weigh more than 185 grams. So there should be this part and this part present also. Okay, so that is why I have drawn the graph this way. So this portion is 0.82. Okay, and they are saying the percentage, I'm taking the probability, because the percentage, if you divide the percentage figure with 100 by 100, you will be getting the probability. So I'm reading it as probability of apples that weigh less than 170 grams is equal to twice, 2 times the probability percentage. I'm reading it as probability of apples which weigh more than 185 grams. Okay, so I am having these two information, and part F's question is find the value of mu or the mean. Both mean and standard deviation are unknown, but we are having two equations also, two unknowns and two equations, so we should be able to solve. And therefore, since this central part is having the probability of 0.82, what will be the sum total of the probabilities of these two parts? It will be equal to 1 minus 0.82. Okay, because the total probability has to be equal to 1. So what is that? 1 minus 0.82, 0.18. Okay, so the sum total of these two probabilities is 0.18. And if I take the probability of, let P of m greater than 185 be equal to x. Therefore, P of m less than 170 should be equal to 2x. Okay, because P of m less than 170 is 2 times P of m greater than 185, and the sum total of these two portions is equal to 0.18. So x plus 2x is equal to 0.18, or 3x is equal to 0.18. Therefore, x is equal to 0.06. 0.18 divided by 3 is 0.06. Okay, so therefore P of m less than 170 is equal to 2x. 2 times 0.06 is 0.12. And P of M greater than 185 is equal to 0.06. And as we know, whenever we do not know the value of the mean or the standard deviation or both of them, we have to use the standardized normal distribution function Z. So Z is the standardized normal distribution function with the mean as 0 and the variance as 1 square. Okay. So Z less than, say, Z1 is equal to 0.12 and P of Z greater than Z2 is equal to 0.06. And since we have to find the values of Z1 and Z2, we should be having the less than sign instead of the greater than sign. So I have to change this sign. So therefore, P of Z less than Z2 should be equal to 1 minus 0.06, which is equal to 1 minus 0.06 is equal to 0.94. Okay. Okay. Now we are in a position to find the values of Z1 and Z2. For this, I don't think you should be giving, you have to give the inverse normal and on. You can just write the values of Z1 and Z2 because these are not the final answers. So menu and then probability and then distribution and then it is inverse normal. So 3. Area is 0.12 and mean is 0 and standard deviation is 1. It is negative 1.174. This time I will be taking more number of digits, not correct to 3 significant figures. Negative 1.174986. Okay. 49, negative 1.174986. Okay. Negative 1.1749867. Most probably I've seen. Let me see once more. 49867. Okay, then there's 9, but let me stop over here. 1, 2, 3, 4, 5, 6, 7. I've taken 7 decimal places. Okay, now coming to Z2. Okay, so menu and then 5 probability, 5 distribution, 3 inverse normal, and area is 0.94. And okay, it is 1.55. I'll be taking 7 decimal places for this also. 55477 is 5 and 3 5. Okay. So Z2 is equal to 1.5547735. And now we know the relation between X and Z, in this case M and Z. So it will be Z1 is equal to 170 minus mu over sigma, that is negative 1.1749867. Okay, I'm multiplying both sides by sigma equal to 170 minus mu, so plus mu equal to 170. And from this, Z2 equal to 185 minus mu over sigma. So the second equation is 1.5547735 sigma plus mu equal to 185. Okay. So these two are two equations with the unknowns mu and sigma. We will be using the simultaneous equations method with our calculator. So I can take sigma as, you don't have to write this, and just for your clarity purpose, I'm just taking sigma, I'm taking it as X and mu as Y. And we have to find mu. find the value of mu, not the sigma. So they will be giving, the calculator will be giving us both the values, but we have to read the y value. Okay. So menu, number 3, algebra, and then number 2, solve system of linear equations, and then number of equations. It is 2. You cannot see perhaps. So this 2, and let us keep the variables as x and y. We have taken x for sigma and y for mu. Okay. And this one is negative 1.1749867 times x. You could have written, I could have written just x also instead of putting the multiplication sign, but you can put the multiplication sign as well, plus y equal to 170. And the next one is 1.5547735. Since I have put a multiplication sign for the first one and doing the same for the second one, equal to 185. Okay. And I come over here and enter. Fine. And I have to read the y value. It is 176.456 and all. Correct to 3 significant figures, it is 176. Let me see whether the question is asking for how many digits. No, find the value of mu. So therefore, mu is equal to 176. Okay. 176 grams. Correct to 3 significant figures. So we have completed solving this question number 10. Thank you for staying with me till the end. Please like and share this video in case you have liked my explanation, and please do not forget to subscribe to my YouTube channel. Your liking, sharing and subscribing will be really helping me a lot. We meet again very soon when we will be solving question number 11 of the same paper. Till then, bye.